All right. So, did you have a chance to watch the video that I sent?
I did.
Okay. Did that make sense?
It did.
I just got confused because I was like, why is this a -1? Why are they putting -1 in here? What is this from? And I was like, oh, it's just any number can go in there. So I just confused myself, and I'm not good at on the spot thinking of things. So apologize for that. All right, so let's look at where are we? Sums of functions and products of functions. Okay, so remember that these are just another way, these functions are just another way to say y equals something. They write it this way so that you can just differentiate between different equations, and not get mixed up which one is which. So if we have these two, h of x equals x plus 3 with the domain of the real numbers, and um, I can't remember what that symbol is called, but the null, I think that's the null set actually. Null set of x equals the, see, they're just trying to say you can use anything for this. You could use a heart, you could use a number sign, use whatever. So the null set of x is equal to x squared minus 6, and the domain is the integers. And then it says find h plus null set of 2. So what this means is we're going to take this function and add it to this function. And this means everywhere there's an x, we're going to substitute 2. Okay? All right, so let's add x plus 3 and x squared minus 6. So that's going to be x squared plus x minus 3 when we add that together. Does that make sense? Okay. Now we're going to substitute 2 in for everything that has an x. Well, oh, before we do that, we need to make sure that this meets our domain. So the domain's the real numbers here and the integers here, and 2 is real and it's an integer, so we can use it. All right, so 4 plus 2 minus 3, so that's going to be 4, 4 minus 1. And that's going to be 3. So when you write the answer, it would be h plus the null set of 2 equals 3. Okay, example 1022. I'm not going to write all of this down. I want you to just look at it. See how it says h of x equals x plus 3, the domain's the reals, and then it says g of x equals 2x squared plus 5, the domain is the negative integers. And then it says find h plus g of 5. So you notice the number that they want you to use to substitute is a positive 5. That does not meet the requirements of the domains. So you can't use that because it's not a member of the domain of h plus g of x. So the problem has no answer, or we say it's the null set or the empty set. Okay. So if you look at that first, then you can save yourself a little bit of work. All right. So 102b is products of functions. So instead of adding two functions together, this one will be multiplying two functions together. So h of x, let's see if this is an actual program problem. No, it's not. So we're going to skip down to 102.3. H of g, negative 4. So this just means that um, h of x times g of x. So instead of writing it this way, they just multiply it together of x like that. Okay. All right. So we've got h of x equals x plus 3, and the domain's the reals. And we've got g of x is x squared minus 6, and the domain's the negative numbers. We check our um, thing, and it says h of g is negative 4, so that meets both of those requirements, so we can use it. So we're going to go ahead and multiply those two functions together. So x plus 3 times x squared minus 6. So we distribute. So this is x cubed minus 6x plus 3x squared minus 18. We combine any like terms. There aren't any. But I am going to rewrite it in order. And then we're going to, everywhere there's an x, we're going to substitute that negative 4 from up here, okay? So negative 4 cubed plus 3 times negative 4 squared minus 6 times negative 4 minus 18. We use our order of operations. We simplify our exponents. So 4 times 4 times 4 is a negative 64. Negative 4 times negative 4 is a positive 16. Positive 16 times 3 is positive 48. And then a negative 6 times a negative 4 is a positive 24 minus 18. We combine all of our like terms. So I'm going to add up the negative 64 and 18 are negative 82. And the positives are 48 and 24, which is 72. So the difference is negative 10. Susan, you tracking? All right, and then the last example there, Susan, is this one that we can do. Look at the domains. Okay, because what are we supposed to substitute for x? Right. So we can't use it because the domains are positive and the real numbers. Okay. So um, for A, B, and C, for A, you've got to add the two functions together, x plus 1 and x squared minus 1. The domain is the real numbers and the integers, and the number that you would substitute is a positive 5. So that one definitely will work. For B, the domain's the negative integers and the reals, and the substitution's a negative number, so that should also work. But those two, you have to multiply the h function times the g function, so x plus 2 times x squared minus 7. And then the last one, it's f of g times x, where f of x equals x plus 6 and g of x equals x minus 4, and it's positive integers. So that one does not have an integer for the substitution. So I'm just going to look at the answer key real quick. Ugh. Okay. So when you go through and you substitute there, you are not going to have a number answer. You're going to get a quadratic equation, and that's acceptable. Okay? Because there's not a 2 or a 4 or something to substitute in. All right? So you're going to get like an x squared plus x plus something. Okay? All right, go ahead and do those 3 practice problems, and I'll put the answers on the board in a minute.